Class 10. Today I am going to start circles. Circles. This is chapter 10. Circles. Chapter 10. General Maths, class 10 students. The first theorem which is given to you, the theorem first, theorem 10.1. It is given that the tangent at any point of a circle perpendicular to the radius through the point of contact. The tangent at any point of a circle. Let this be the point. Let this be the point on the circle. The tangent at this point. This is the tangent at this point. This is the tangent at any point. This is the point of a circle. Is perpendicular to the radius. This is perpendicular to the radius through the point of contact. This is the point of contact. This is the point of contact. Point of contact. This is the point of contact. Now this is the center O. So this is the tangent and this is the radius. So radius, this is perpendicular to the tangent. It is perpendicular to the tangent. So we have to prove that radius is perpendicular to the tangent. This radius is perpendicular to the tangent at the point of contact. At the point of contact. Or we can say that radius is perpendicular. Radius is perpendicular. Radius is perpendicular to the tangent. Radius is perpendicular to the tangent at the point of contact, we can say. At the point of contact, we can say. So, how to prove it? Now you will see how I am going to prove it. Here. This is the circle. And here, this is the tangent. This is the tangent. And this is the center of the circle. Y, X. This is the point of contact P. Now, what is given to you? It is given X, YX. YX is the tangent. YX is the tangent at point P. YX is the tangent at point P. OP is the radius. OP is the radius. And O is the center of the circle. We have to prove that. We have to prove that OP is perpendicular to YX. We have to prove this. Now, to prove it, let Q be a point on YX. Let Q be a point on YX. Q be a point on YX. And OQ is joined. And OQ is joined, which intersect the circle at, let this be R, at R. Let this be R. Now proof. See, OQ, this is equal to OR plus RQ, which I get from the figure. OQ is equal to OR plus RQ, which I get from the figure. Now I can write OQ is equal to, instead of OR, we can write OP plus RQ. Why? Since OR is equal to OP, radii of the same circle. Now from this we can conclude that OP is less than OQ. From this we can conclude that OP is less than OQ. So we can make a statement here. That for every point on the line yx except the point P, for every point on x except P, except this P, OP is the shortest of all the distances of the point O to the points of yx, This OP is the shortest of all distances of the point O to the points on yx. This is the shortest. So OP is perpendicular to yx. So OP is perpendicular to yx. Since we know that perpendicular is the shortest distance, we know that perpendicular is the shortest distance. Therefore, OP perpendicular yx. Good. 10.2. See theorem 10.2. The lengths of the tangent drawn from an external point to a circle are equal. That is, the length of the tangent drawn from an external point. This is P is an external point. Length of the tangent. This O is the center. So length of the tangent from an external point are equal. Length of this tangent and this tangent. That means figure is like this. The length of the tangent from an external point are equal. That means this is the external point, this is the tangent, PQ and PR are the tangent, and these two tangents are equal in length. That is, PQ is equal to PR. So what is given to you? Given that O is the center of the circle. O is the center of the circle. PQ and PR are the tangents to the circle at point Q and R. PQ and PR are the tangents to the circle at point Q and R. To prove that, we have to prove that PQ is equal to PR. We have to prove this. Now construction OP, OQ, OR are joined. This is the construction joined. OP, OQ, OR are joined. Now proof. Let us take two triangles. In triangle POQ and triangle POR. See, OQ is equal to OR because they are the radii of the same circle. Because they are the radii of the same circle. Radii of the same circle. Now, angle QP is equal to angle ORP equal to 90 degree. Why? This is from theorem 10.1. That is, radius is perpendicular. Radius is perpendicular to the tangent. Radius is perpendicular to the tangent at the point of contact. Since the radius is perpendicular to the tangent at the point of contact, so these two angles are 90 degree. This is 90 degree, 90 degree. And now here OP is equal to OP. This is common side. Therefore, triangle PQO is congruent to triangle PRO. PQO is congruent to triangle PRO from RHS. Right angle, this is the hypotenuse and this is the side. So therefore PQ is equal to PR CT. This is proof. Now I am going to start exercise 10.2. See exercise 10.2, first question. From a point Q, the length of the tangent to the circle is 24 cm and distance of Q from the center is 25 cm. The radius of the circle is, see, exercise 10.2. 1. From a point Q, the length of the tangent to the circle. This is the circle. From a point Q, this is the point Q. This is the point Q. The length of the tangent to a circle is 24 cm. The length of the tangent to the circle, let this be R. This length of this is 24 cm. And the distance of Q from the center, it is 25 cm. We have to find the radius of the circle OR. We have to find OR. Now see, here it is given, what it is given? QR is equal to 24 cm and QO is equal to 25 cm. This is given to you. Now by the help of Pythagoras theorem, see, OQ square is equal to OR square plus RQ square. So OQ square, that is 25 square, OR square plus 24 square. So 25 square, this is 625, is equal to OR square, this is 576, 24 square. This is 576. Now 625 minus 576 is equal to OR square. So 625 minus 576, 576, 15 minus 6, this will be 9. 11 minus 4, that means 49 is equal to OR square. OR square. Therefore 7 is equal to OR. That means 7 centimeter is equal to OR is your answer. So the back answer is 10.2A. Option it is given A. See 10.21A here. So option, this is 7. This is the answer. So 7. This is the answer. Question number 2. The figure it is given here. See TP and TQ are the two tangents, and this angle is 110 degree. We have to find PTQ, this angle. So you see, this is given. See, because the radius is perpendicular, TP and TQ, these tangents are given to you. These are the two tangents. And OP and OQ are the radius. So this is 90 degree. We know that radius is perpendicular to the tangent. Here radius is perpendicular to the tangent. We know this. 90 degree, 90 degree. This will know this. We have to find out this value. We have to find out this value. So OPTQ is a quadrilateral. This is a quadrilateral. This is a quadrilateral. And the sum of the interior angles of a quadrilateral is 360 degree. Therefore, angle POQ plus angle OPT plus angle PTQ plus angle TQO, this is Q, is equal to 360 degree. Now POQ, this is 110 degree. OPT, this is 90 degree, and this we have to find out, and TQP, this is 90 degree, so this is equal to 360 degree. So 110 plus 180, 290 degree plus angle PTQ is equal to 360 degree, angle PTQ 360 degree minus 290 degree. So 360 degree, 290, 0, 16 minus 9, this is 7, 70 degree. Angle PTQ is equal to 70 degree. This is your answer. Now question number 3. If tangent P and PB from point P to the circle with center O are inclined to each other at 80 degree, we have to find POA. So the figure will be, this is the circle, this is the point P, and B, these are the two tangents to the circle with center O, are inclined to each other. This PA and PB, these two are the tangent with center O, and these two tangent are inclined to each other 80 degree. Yes. We have to find POA. We have to find POA. Yes. Now see one thing, that we can directly say that triangle POA is congruent to triangle POB. We can say this. These two triangles are congruent from RHS. How? You see, this is 90 degree. Radius is perpendicular to the tangent. And these two are the radius. They are equal, same circle. And this is the common side, which is the hypotenuse of the two circles. Two triangles. This is the hypotenuse. OP is the hypotenuse of these two triangles. So from RHS, these two triangles are congruent. So this angle is equal to this angle. So angle APO is equal to angle BPO. So this will be equal to 40 degree, half of 80 degree. This is 80, so half is 40 degree. This is 40 degree. Now, in triangle AOP, angle OAP plus angle APO plus angle POA is equal to 180 degree. So OAP, this is 90 degree. APO, this is 40 degree. And POA, we have to find out. This will be 180 degree. So 90 plus 40, this is 130 degree. Plus angle POA, 180 degree. So angle POA, 180 minus 130, this comes out to be 50 degree. This is your answer. So 10.3, question number 3, answer 10.2. This 10.2, question number 3A. 3A, your A is 50 degree. And this is 50 degree. Prove that the tangents drawn at the end of a diameter of a circle are parallel. Question number 4. That is, this is the circle. This is the circle. Center. We are drawing two tangents here. Two tangents. P, Q, R, S. These are the two tangents, and we have to prove that these are the two tangents at the end of a diameter. See, this is the diameter. At the end of the diameter, there are two tangents. These are the point of contact. At the end of the diameter, there are two tangents, and we have to prove that these two tangents are parallel. These two tangents are parallel. So given O is the center of the circle, O is the center of the circle, PQ and RS are the tangents at point A and B. To prove that PQ is parallel to RS, we have to prove this. Now proof. OA is the radius of the circle and PQ is the tangent at point A. So angle OAQ is equal to 90 degree. This is from theorem 10.1, that is radius is perpendicular to the tangent. This is from theorem 10.1. Tangent at any point of a circle is perpendicular to the radius through the point of contact. Now similarly, again OB is the radius of the circle, RS is the tangent at B. So therefore angle OBS is equal to 90 degree to theorem 10.1. Same, this radius is perpendicular to the tangent. Radius is perpendicular to the tangent. Now 1 plus 2, angle OAQ plus angle OBS is equal to 90 plus 90, 180 degree. So therefore I can say PQ is parallel to RS. Why? If the sum of the interior angles, on the same side of the transversal is 180 degree. If the sum of the interior angles on the same side of the transversal is 180 degree, the lines are parallel. If the sum of the interior angles on the same side of the transversal is 180 degree, then these lines are parallel. The length of the tangent from a point A at a distance 5 cm from the center of the circle is 4 cm. Find the radius of the circle. The length of the distance from a point A at a distance 5 cm from the center of the circle. The length of the tangent from a point A at is 5 cm from the center of the circle. 5 cm. The length of the tangent is 4 cm. Find the radius. This it is given to you is 5 cm, and this tangent length it is given to you 4 cm. This is 90 degree. We have to find the radius of the circle. So, for the help of the Pythagoras theorem in triangle POA, by the help of the Pythagoras theorem, OA square is equal to OP square plus AP square. So 5 square is equal to OP square plus 4 square. So 25 is equal to OP square plus 16. So 25 minus 16 is equal to OP square. 9 is equal to OP square. 3 is equal to OP. This is here. So 3 centimeter is equal to OP is your answer. Question number Two concentric circles are of radius 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. Concentric circle. Concentric circle. Length of the chord of the larger circle. This is the chord of the larger circle which touches the smaller circle. Now the radius of the larger circle is 5 centimeter and the radius of the smaller circle is 3 centimeter. Is A, B, C. We have to find the length of this chord AB. Again, radius is perpendicular to the tangent, therefore this is 90 degree. Solution. Question number 7. This is question number 7, solution. In triangle AOC, OA square, Pythagoras theorem, OA square is equal to OC square plus AC square, Pythagoras theorem. You all know about it. 5 square is equal to 3 square plus AC square. 25 minus 9 is equal to AC square. So 16 is equal to AC square. So 4 is equal to AC. That means AC is equal to 4 centimeter. Now we know one thing, that the perpendicular drawn from the tangent, perpendicular drawn from the center bisects the chord. We know that there is a theorem which you studied in class 9. There is a theorem which you studied in class 9, that is perpendicular drawn from the center of a circle bisects the chord. So therefore AC is equal to CB. Therefore AB will be equal to 4 plus 4, that is 8 centimeter. Now let me see the answer, question number 7. See, question number 7, that is 8 centimeter. So this is over. Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. The figure it is given here. Let's see. Question number 8. So here it is given. That ABCD is a quadrilateral. Circumscribing a circle. Even ABCD is a quadrilateral circumscribing a circle. ABCD is a quadrilateral circumscribing a circle. Is a quadrilateral circumscribing a circle. To prove that AB plus CD is equal to AD plus BC. AB plus CD is equal to AD plus BC. Now proof. You see, dr is equal to ds. Why? It is from theorem 10.2. The lengths of tangents drawn from an external point to a circle are equal. So dr is equal to ds. Now again, similarly, I can write CR is equal to CQ, equation 2. Same theorem. Now 1 plus 2, that is dr plus cr is equal to ds plus cq. So dr plus cr, this is dc, is equal to ds plus cq, equation 3. Now see, again, your AS is equal to AP, or I can write like this. AP is equal to AS. The same theorem, this is theorem 10.2. Theorem 10.2, that is, the lengths of the tangent drawn from an external point to a circle are equal. So this is equation 4, and BP is equal to BQ. Same theorem, theorem 10.2, this is 5. Now again, 4 plus 5, that is AP plus BP is equal to AS plus BQ. AP plus BP, this will be AB, that is AS plus BQ. This is equation 6. Now add 3 plus 6. What do we get? AB plus DC is equal to AS plus BQ plus DS plus CQ. Now AB plus DC is equal to, you see, AS plus DS. AS plus DS, this will be equal to AD. AS plus DS will be AD. And BQ plus CQ, this will be equal to BC. And this is proved.